the automobile has become a computer, Craig Smith is the author of The Car Hacker's Handbook and is the founder of Theia Labs. Craig, welcome to Software Engineering Daily. What is the Car Hacker's Handbook?
Car Hacker's Handbook is a book that was designed to kind of go along some courses, some physical in-person courses for a bunch of university students at the University of Virginia Tech. They have a USCC, it's a cyber camp there, and this particular book is just a general overview of different ways of attacking cars from a security perspective, primarily. It goes to the gamut of, just your initial assessment of a vehicle to, all the way down to depending what you're after, like how to go about that type of research.
Could you tell me an anecdote about just an incident or a story that illustrates why car hacking is a relevant topic to discuss?
Well, for me, I came from a software world background, and I got into cars about 2008, 2009. And I started applying some of my security research to vehicles then. And it's one of those things I think at first it was just kind of interesting. It's a different medium, than maybe doing an assessment on a website or something. So it was kind of exciting just to see physical stuff move. But at the same time, once you start, getting success with some of your research, then it kind of really hits home as to how this is really a safety issue. And the more you start looking at it, the more you're starting to see some of the same problems we've seen 10 years ago in the web server internet world. It's just kind of like an industry that hasn't been connected to the internet as well or as long, and they're making some of the same mistakes. So I think because lives are at risk and your family's in the cars and these kinds of things, we want to work with the industry to kind of make sure that they have the lessons learned from the internet and what we've learned there, and kind of not repeat all the old problems that we did before.
What are those lessons?
Well, one of the ones I'm seeing is so some of the knee-jerk reactions, I guess, for some of the security stuff coming to the automotive is you'll have people basically asking or saying that they're about to put in a firewall type system to the car, which is fine. It gets rid of certain types of attacks. If you're having, say, an attack over you have a dongle in your car or a connector port on your steering column. And that port's typically used for say e-checks and environmental kind of checks or just diagnostics in general. An attack could be that you put in one of those insurance dongles like Progressive or somebody to monitor, your driving safety, but that could have a vulnerability in it. And if that dongle has a vulnerability in it, it can do things like control your car, cause an issue. So firewall could stop those, but that's all it's going to really stop. It's just like putting a firewall on the internet. It helped a little bit, but that didn't solve any problems, really. It's just a small hurdle to get through.
This Wired article that broke recently, hackers remotely killed a Jeep on the highway that was being driven by a reporter. It was all planned. Basically, the reporter just said, I'm going to be driving along. I don't know what these hackers are going to do to me, but I'm prepared for it. And the hackers hack into the Jeep and they kill the engine. They can control the steering. They can do all these sorts of different things. Somewhat terrifying video. And I'll put it in the show notes for any listeners who haven't seen it. But this video about the killing a Jeep remotely, did anything in that video surprise you?
From a technical perspective, no. That's the type of research you'll do. If you work for the auto industry, which I do, and you're doing a security audit, just like if you were to do a security audit on a website, when you gain access to a website, you'll have full control of the website. So when you're doing that with a vehicle and you're successful, you'll have full control of the vehicle as well. So especially with more modern cars, it's all network and software based. So it's really the same kind of attacks. It's just applied to now a physical medium. So the research itself didn't surprise me. Conducting on a public road did. I'm not a huge fan of that, but
I'm sorry, you were not a huge fan of what?
Conducting that research on a public road. That the only thing that luckily nobody got hurt, so therefore
kind
it
of
wasn't
exhibitionist, right?
It was, and the media, loves that type of stuff, which gives you more, I guess, platform to discuss the issue. But I personally, I don't think I would have done it that way. But it is what it is, and luckily nobody got hurt. So
Yeah,
at
so in
least
the
something we're
video,
talking
like
about.
he's literally driving on the highway and they kill the engine and he's like pulled over and the shoulder isn't even big. Like that could easily have been a fatal accident.
Yeah, and then the thing is, had that been an accident, it would have been federal prosecution would have happened after that. So, and then it would be a whole different topic. And again, I'm just glad it didn't happen because yeah, it went from being something we're discussing to something that just would have been obvious violation.
So, did the hackers pick that Jeep Cherokee deliberately, or could they have picked any car and just found an exploit?
Well, you typically like for that type of research, what you're going to look for is you're going to look for one that's going to be most likely to have whatever your end goal is. So in their case, it's they were interested in like controlling steering and stuff like that. So they typically focus the research on things that had like automatic parking and things where there's like some kind of software piece that'll control the steering wheel. And so like if you can maybe get some other vehicles, because there's driving assist and that kind of stuff. But in this case, they picked certain cars because they were high end. They had some of the features they want to try and ultimately control. As far as getting a vulnerability goes, it's it depends your distance, right? So if you wanted one that had cellular over the internet, obviously you have to pick a car that has those things. If your car doesn't have some kind of like OnStar capability or some kind of dial home capability, it may not be on the internet. So therefore your reach may be Bluetooth or maybe Wi-Fi, something of that nature.
But one thing that stuck out from this Jeep hacking incident is the the response from the car manufacturer. Some of it was basically like, how dare you expose this security vulnerability and present this openness, which almost just, it seems to me it's like you guys are kind of missing the point and looking at the situation incorrectly. Like hasn't time shown that the more light that we shine on these issues, the easier it is to fix them?
Yeah, and I think that's exactly like the problem I was mentioning about things we learned 10 years ago in the internet world. I mean, it was the same back then too. People would come out, vulnerabilities from Microsoft, and initially it was a bunch of cease and desist letters and suing people to try and get them to not talk about the vulnerabilities. That didn't mean the vulnerabilities weren't there, of course. It just they're trying to make you not discuss them. And that's evolved over time to the point that there's bug bounties, and we pay people to find these bugs for us. And so that's exactly right. We need to look at those lessons learned and adopt those to have this kind of this work to make the cars safer. I mean, that's what everybody wants. The auto industry wants it. Consumers want it. Security researchers want it. And it's just a matter of understanding how to work together.
I do want to get into more technical engineering topics eventually, but I would just to set the stage a little more, get more of an understanding of how you are seeing the response to this media event in the car hacker community. Was this, I mean, you said it wasn't really surprising to you from a technical perspective, but has it had any sort of splash? I know these guys are presenting at Black Hat, or they did present. So what kind of impact has this had? Any kind of impact on the community at large?
It has. I mean, it's one thing that's happened from all these media events like this is that it gets people at board level more aware of this stuff. If you talk to some of the security folks in the automotive community, or not community, but in the automotive companies themselves, they typically knew about a lot of these problems. They've had the same concerns for a while, but they didn't necessarily have the funding or the voice. And it's mainly because at the top level, it wasn't as obvious, or it seemed more niche, or it seemed more theoretical. So having a lot of this media and having just general people know about it is going to allow, I think, a lot of the security teams that already work there to finally have the funding and the actual voice to say like, well, I know this was just what looked like a bug fix, that was going to be in some eventual release of the car, but because it's a security bug, it's not something we can wait 5 years to kind of see it, the next model vehicle or whatever. They need to have it sooner rather than later. It's a different type of bug. It needs to be handled differently. And before they weren't getting that voice.
And from the CTO or CEO level perspective, how do you delegate to the engineers or communicate to the engineers, okay, we're going to throw money at this, or we're going to throw resources at this, or we're going to throw time at this? Or do you say, like, hey, we're going to put an extra year of development time into each car to make sure it's bulletproof security-wise? What are the higher level initiatives that have to be taken to have proper precautionary measures?
Well, our current situation makes it a little difficult. The way vehicles work, or at least design process works, is they build out their car, and after they've designed the car, about 5 years later, it comes to production. And then once it's on the road, they typically support it for another 10 years. So that means if you're working on something right now and you think, okay, well, I'm going to add this security feature, you're not going to see it for another 5. And it's supposed to, in theory, if they don't have over-the-air updates, stay solid for basically 15 years after you've developed it. There's no software company that doesn't put a patch out in 15 years. So they're in a tight spot because we've added a bunch of features. We didn't necessarily design the cars with security in mind before adding the features. So it's tough. I mean, we can definitely make the newer ones more secure, but there's a whole question of what do we do with the cars on the road right now?
Let's start talking about the engineering. Give me a high-level overview of what a car computer system looks like.
Well, it's a bunch of computer systems. There is, say, like your engine control unit. That's a little embedded system that controls most of your engine-related stuff. You may have another one for your body control, which does a lot of the gateway, connecting the networks together. And then you have things that are typically focused on by security researchers, which are your infotainment center, that navigation console in the middle. That's basically a miniature OS. It could be like Linux or Windows CE or something called QNX. They have all the features you would think a normal desktop would have. And sometimes you'll have another like telematics unit that will either be part of that one or be separate, and that's another small embedded system, but that one typically has your Wi-Fi or your cellular connections.
So this is a multi-operating system environment. What is the method of communication between operating systems?
Typically, it's a bus network. The one you hear a lot is CAN bus. It's a relatively simple protocol, maximum of 8 bytes to the packet. No source or destination address, just a kind of like a category ID of what's being discussed. And so it's a very efficient, very fast, well, as far as car networks go, fast protocol that does a good job handling things like static electricity and that type of stuff in the air. But security wasn't a part of it. It typically was meant for closed system and still used in closed systems like manufacturing, as well as cars.
So we'll definitely get into CAN bus in more detail. But I'd like to talk a little more about the high level. Why do certain components of the car choose, to run? Some of them run a version of Windows. Some of them run, maybe I think they use was it Cubix or
QNX.
Okay, right. So how do you choose between the different operating system components?
It's typically just a lot of the car companies will buy most of their parts from somewhere else. They're called like tier suppliers. So at some point in time, there's usually like some bid process or something that goes on where they decide that this particular radio unit is going to be put in place. Sometimes it's based on interface, sometimes it's based on features. It's really up to the tier supplier what OS they're going to use. But from the auto manufacturer's perspective, they typically don't even ask.
Do those parts come from China?
They're manufactured all over the place, but yeah, some come from China. A lot of embedded systems do. But yeah, the parts are from all over the place. Like the different components are from many different companies as well. And a lot of times they're shared between vehicles, which is one thing you'll see sometimes if there's a bug or a vulnerability. You'll see it in multiple makes and models. It's because the supplier is the same. Like Takata airbags is a good example. The airbags across a bunch of makes and models. That wasn't a security bug, but it's a similar issue.
When you saw this, these laptops with deliberate security vulnerabilities such that adware, malware could be delivered to the end user. Did you think about the applications of that type of technology to malicious car attacks?
I haven't really spent a whole lot of time working on that aspect. It's definitely a possibility. There it would be a target that you could do that with. Um, I mean, again, I haven't seen anybody doing something like that. I'm not sure exactly where you'd want to place those kind of bad components. But it is something that's feasible.
What parts of a car are most susceptible to hacking?
The ones that are like basically the infotainment center. So it's probably the most susceptible. It has what we call it, the highest attack surface. Attack surface is basically just your amount of inputs. So in the case of a vehicle, it's things like your network, DVDs, USBs. So if you have like cellular, Bluetooth, all that coming in, each one of those is a new attack surface. So the more of those you have, the more chances you have of a vulnerability. And those units are 9 times out of 10, if it comes from the factory, they're attached to the car's network. So once you're in them, you can control the car. If that's your end goal, your end goal could also just be to turn on the microphone and listen to the car, get the contacts out of the car, those kinds of things.
Why couldn't the infotainment center be more comfortably segregated? It seems like I think of infotainment center, it's like my computer monitor. I don't think of my computer monitor as vulnerable to security problems.
Yeah, it's typically it's things like the reasons why they're connected are things like if maybe you have the feature where if you're driving faster, the radio gets louder. It has to know the speed for that. If you want certain types of controls on your dash for maybe controlling your climate system, those things, have to now be connected. So all the features you have, or you want like a command console to control your vehicle or get feedback from your vehicle, if you want those features, you have to connect. Now, you could do some segregation. There are ways to do like a secure gateway and stuff for that type of thing. But unless you got an aftermarket radio, you're probably not completely disconnected from your car network.
And what parts of a car are not susceptible to hacking?
It's going to be things that really have no attack surface. So if you have like a closed looped area, where you can't really get to it remotely, you can't get to it through any kind of. I mean, there are of course physical attacks you could do, but that also goes with hot wiring and everything else. But I would say from the type of the Jeep, they would be separated in such a way you just can't get to them, or they're so simple of a device that you could have reasonable assurance that they're fairly secure.
So the cars that you study, it sounds like you're more concerned with the susceptibility to remote hacking rather than hacking from the point of a physical access point.
Yeah, I mean, it totally varies on the client. But of course, I think the overall biggest risk is when you can attack a car from anywhere in the world. That's the scariest of scenarios. Now, if you're like, say, a taxi driver or somebody who drives a police car, people in the back seat are a risk. It's an internal one where the wires run. There are things in that case you'd have to take into consideration that a normal person may not have to take into consideration.
So we will get into more of those details, but let's talk a bit about your occupation. You work at Theia Labs. What is Theia Labs?
It's just a consulting firm. We do a lot of security, reverse engineering, some prototype designs of, like new hardware, typically security related, but not always. It's just a general kind of consulting firm. We specialize in reverse engineering. So that's kind of what got us in the cars.
So what kinds of customers do you have?
Well, it ranges. Sometimes it's like when it's web-based, a lot of times it's like banks, health insurance, that type of stuff. Embedded can be medical, cars. It's been obviously really big this year. Actually, this year that's been almost all of our focus has been on automotive, just because there's been such a demand for it.
So the customer comes to you and says, what exactly? Like, if an automotive company comes to you, they say, I want you to vet my device for vulnerabilities, or I want you to vet the entire car, or what exactly is the customer saying?
I mean, that's right. It's just like if you were to do like a website, you would want somebody to attack your website, see if they can find any issues with it, tell you what the issues are, maybe suggestions on how to fix it. Car companies the same way. It's sometimes a full car, sometimes it's just a new component. Sometimes they're maybe evaluating a couple devices, and they want you to kind of, put it to the ringer, determine, from a security perspective, which one holds up better, those kinds of things.
And what is your background? How did you end up in this world of reverse engineering?
Well, I've been doing reverse engineering for a long time. I started as a security pen tester, did a lot of reverse engineering, focused on removal of DRM protection. For as far as cars go, what happened with that is I bought a Honda Civic back in 2008. The commute was like a 2-hour commute from I was in Cincinnati at the time, driving up to Dayton. And this is the first time I had like a nice touchscreen display. But what I wanted is I really wanted music videos on my my display. Maybe not the most mature thing in the world, but I thought that would be a nice feature to have. So I went about the process of reverse engineering my radio or my entertainment nav system, so I could figure out, okay, well, what is this? How does this work? How am I going to go about this process? And as I went through this learning process, I document the whole thing, put it up on the internet, and that got the attention of some companies who want to know if I'd come and mentor certain kind of vehicle hackathons. So I went and did that with a bunch of students, and that was a lot of fun. And I had so much fun doing that I created a group called Open Garages, which is just a community group of mechanics, performance tuners, security people that just kind of get together once a month and just talk about cars, what they're working on, sharing information, that kind of stuff.
So you knew about cars before this, or did you just know about electronics and computer systems?
Before I went about going after my nav system?
Yes.
I knew about electronics. My background is software, so my electronics is, kind of dabbling Arduino, that level. Made a couple circuit boards that are custom, but, not a ton. And then, in the last couple of years, I've done a lot more electronics and a lot more automotive. I didn't come from a mechanics background.
So if somebody wants to dive into car hacking, you don't need to know that much about the automotive aspects of a car. You just kind of need to have some kind of computer background.
Yeah, typically when I'm training people on the subject, if they come from, say, a security background, usually the training class is 1, maybe 2 days. If they, say if it's students who are maybe freshmen in college, but good computer science students, about a week. Because really, all you really have to do from a software perspective, it's different. The cars are mainly software, so it's just understanding the differences between maybe your desktop and the systems running in your vehicle. And so once you understand those differences, the rest is the same. So it's not a huge hurdle to come into, and you don't need to know very much about vehicles unless, of course, you're going to try and do things like make new components for a vehicle or make a self-driving car. Then it would definitely help.
So you've talked some about the attack surfaces of a car. Could you define the term attack surface once again and outline some high-level attacks that could occur on a car across these surfaces?
Okay, so attack surface is again, you just view them as inputs into whatever it is you're focused on. So if we're talking, say, a navigation system, the inputs could be the CD or DVD player that has map updates. It could be a USB port. It could be your Bluetooth connection. If it has like digital radio, such as XM or Sirius, it could be one of those. It's cellular networks if it has a way of dialing in. So all these are methods of having input, which for an attacker would be ways of getting code into the system. And typically they do it by looking for bugs. So in the case of my nav system for my Honda Civic, the way I got in was the DVD. They have a map update that also has these DLLs in it for doing just kind of like OS updates. And by looking at those and then creating some of my own and figuring out what kind of little checks they had in place, I was able to get my own code running on the infotainment center. Describe
in more detail the communication model of a car. both in terms of how the car communicates with itself across buses and how it communicates out to the internet.
Okay, so those are two different protocols. The one within itself is the CAN bus, and it's a very simple, fast, efficient network. No real security is involved in that one because the goal when that was designed was really just to make sure there's a reliable packet going back and forth. The connection back to like over a cell line, those are different. So those are like when you have the little phone home for help kind of buttons. Those create a connection back to the data center of the auto manufacturer, and there they'll have a special network designed for the vehicles to kind of control and regulate those. And some security is put in place usually at the data center level. Those are typically separated from the other network, to varying degrees. But that's your traditional IP network, so that you would have on a normal, laptop internet kind of thing.
The CAN bus was not designed with security in mind at all. How dangerous is this? Is this like something that fundamentally we need to patch? We need to make some new communication protocol, or do we just need to implement something within the CAN bus protocol?
You're not going to. It'll be very difficult to implement something, I think, within the existing CAN bus protocol. You can do it. I've seen attempts at it. You got to be careful. Like, so if you had, say, encryption, that's a knee-jerk reaction I see a lot. Is, well, let's just encrypt CAN. You have to first realize that the packet's content themselves isn't really that important. It's not like private. We don't really care if somebody knows what that is. So if you add something like encryption, which does kind of prevent replayability, which is what people are afraid of, is replaying packets. But by adding encryption, you'll typically, because you only have 8 bytes to work with, you will add a bunch of packets chained together, because encrypting will add size. So if you're going to slam on your brakes, you want that packet to not take 5 packets for 1 bit to say, let's break now. And so you got to be careful with that type of stuff. Timing matters, a bunch of other stuff matters. So it most likely would be looking at a different protocol or a different way of doing the bus architecture, maybe make it not so much of a bus.
Can't you increase the bit width?
You can have longer ones, but typically that's almost the same thing as chaining, right? So if you chain a bunch of 8-byte packets together and you just have one really long packet, you're still processing a large amount of data for 1 bit.
So what are the attacks that can be carried out over CAN bus, or am I thinking about that the right way? Are attacks carried out over CAN bus?
Well, yeah, and I think the way you can look at it is like a payload. So once you have a vulnerability, what do you want to do with it? So if it's a computer, like, do you want to run the calculator program? That's a payload. For cars, it's what do you want to play on the CAN bus to control the car? So the CAN bus packet, it really can control anything because that's how the vehicle communicates. And so whenever you hit buttons and stuff, for the most part, unless it's hardwired in, it's going to send a packet. Could be CAN, could be another bus protocol, but that's how it works. And so if your payload is to unlock the car door, start the engine, those are things you can do.
How does car security modeling compare to classic models of computer security? I know you've already compared it somewhat to the early days of web security, but I'm curious more from like an academic sense of how we approach security. How does car security modeling compare to that?
Well, it's a little bit more messy. What I like to see done is threat modeling, which if you've done web designs and that type of stuff, you hopefully have done some threat modeling. But it varies on how complex your system is if you had an opportunity to do something like that. It's typically just a process of mapping out all of your inputs and designing what we call threat boundaries. So if something goes from, say, outside inside, or if they get to some database internally to that, you may have crossed a couple threat boundaries. Then you label these inputs with a risk score. And so you give them a score, and it tells you, like, something you can focus on. Like, okay, well, this one's the from all the way on the internet to all the way to our backend database where we keep credit card numbers. This is an area we have to try and really focus to make sure it's as secure as possible. The vehicle threat model is the same thing, except now you're kind of dealing with hardware components. You're dealing with different types of like wireless inputs, that kind of stuff. So it's a wider. You have to take a step back when you start on this one to kind of look at the car from kind of signals is it doing. Is there a tire pressure monitoring system coming from your tires? And is that something that somebody can attack? And you document those, and then you start moving in, and you get deeper and deeper and deeper till you're talking about internal components between this embedded system that talking to this other embedded system, and you map them all out that way. So the process takes longer, but it's basically the same process.
Vehicles have become increasingly electronic, and the electronic systems are often closed off to mechanics. What does this mean, and how does this prevent? Does this prevent mechanics from correctly diagnosing problems when maybe these electronic systems are proprietary or just not well documented? Or
yeah, absolutely. It's a big problem, and it affects security as well. One of the things that happened with Open Garages when I first started it is I assumed a bunch of security people would come, and we do like car hacking. But what mainly happened was mechanics came because they needed these pieces to help like reverse engineer the car. It's too expensive for a mom and pop to deal with. If you're a dealership, when you're only working with one type of make of vehicle, you can pay $25,000 for that information. But if you have multiple types of vehicles you're working on, you can't afford to do that. And so you have to go for alternatives. And this lockout's it's just troublesome. It's not helpful at all. And it prevents, it adds this extra hurdle even from a security research perspective, because now we have to figure out, what's this doing? We have to kind of guess about it. And we do this every single time we're doing any kind of research, and nobody wants to do that part. We want to do the actual research part. And it definitely needs to be opened up more. I think then once you have it opened up more, not only can you do better repairs, those kinds of tweaks, but you can also, from a security perspective, I can then check, say, your infotainment center to see, is it infected? Has anybody modified this? Right now, I can't even do that because there's such a tight lock on this recently. When things became software-based, there was a power grab for who controls that information. Right now, it's purely the automakers. They feel they own your car. GM actually made that statement from the Copyright Office not that long ago. They said because cars are primarily software, and you can copyright software, there's an implicit copyright on the vehicle, and GM owns it. You don't own the car, GM does. And I don't think people realize that GM feels that way, or the Auto Alliance feels that way. And it's a problem. I think we're about to come to terms with that and have to address that real soon.
And how is that going to manifest? I mean, is that going to be like big conflict that will be really hard fought and difficult to resolve, or are the automakers going to come around in a sensible win-win fashion?
Well, of course, I hope for the latter. I really hope we can kind of do lessons learned here, work together with the community, because everything is kind of better, I think, when you do that. You get really cool modifications to your vehicle. You get a cool fan presence. You can get better security from independent researchers. But I understand their reluctance because litigation is so high in automotive. That's really where a lot of this comes from. I mean, some of it, yes, is money. But the other part is they're afraid of being sued for things. So they always take this really cautious route. Well, if we let you modify your car and you hurt yourself, and you're going to sue me. We just
but maybe it's cautious in the short term, but in the long term, it's absurdly risky, right?
Yes. No, I definitely think that's the better route to go. Being more open is going to ultimately provide better safety, security, and it will just make a better environment in general. And we just have to get over this little learning curve.
What about Tesla? Is Tesla like a leading indicator in how to properly do this, or are they just as kind of like cloistered and conservative about their security disclosures?
Well, I mean, everybody's got room to improve, but I think Tesla's doing a pretty good job. They have the over-the-air updates. They've done them consistently. They've done them well. I know they focus a lot on security. They have bug bounty programs where they'll pay if you find issues with the car or their website or their phone app. That's fantastic. And I want to see more of that type of stuff. It puts them in a better position. They're, most likely working on some stuff for right to repair, all that good stuff too. But as far as I know, they haven't yet. So everybody has some places to work on. They have that ability being a smaller company and a kind of like, I guess, a startup, as you will, that they can kind of invent things knowing what they know. And I think that's why they're a good one to look at, because if you didn't have all that baggage, you can look at Tesla and see like, well, if we could start fresh, this is probably how we would do it.
So software updates is an interesting topic to discuss here. I would love to know, how does a software update get issued? What is the strategy behind that? And is there a potential nightmare scenario where a hacker gets into the central network of a company like Jeep and pushes out some software update that hits every internet connected Jeep on the road, just delivers malicious software all at the same time? Maybe you could talk some about that.
Sure. Well, I mean, we're kind of already connecting back to the data center, so we already kind of have that connection. So that nightmare scenario is already there, but we don't always have the update capabilities to fix things. So why, yes, there is a chance that somebody could get in, and if it's bypasses whatever PKI infrastructure they have for secure update and brick every vehicle, it's about the same likelihood as bricking every iPhone. Technically possible, somebody can hack into Apple and do that. But when the updates are done right with enough controls, it hasn't happened to date. It's not saying it can't happen. Everybody's phone won't stop working, but it's not as likely. And the thing is, while you're adding attack surface, you're adding some risk, adding an over-the-air update. At least that one has capabilities of adding security, whereas the other ones are just adding risk.
And the update models is, I imagine this isn't like a continuous delivery type of system where they're shipping code changes to cars on a super regular basis. How often are software updates issued to cars? Kind
now, very rarely. And then how often to do it's definitely up for debate. Right now, because they're not over the air, it's kind of like a recall phase. It's like, do they ask you to take off work and come into the dealership? Do they try and ship you a USB key? Which ones cause that? That kind of thing. The over-the-air ones, they have their own kind of things they have to deal with, such as, if like, you don't want a really big update either, where somebody's like, oh, you want to drive your car, well, you got to wait 30 minutes while I install updates. We don't want to get to that scenario. Nobody's going to wait in their car for 30 minutes while updates occur. So there's a bunch of extra challenges they have to do, but they're things that are solvable.
Let's zoom out to some high-level scenarios. Who wants to attack cars? Are these domestic agents or foreign agents?
It could be a bunch of different things. I can come up with scenarios. I can come up with incentivized ones, like if you wanted to lock out somebody from a car until they paid you some money. They turn on the car, it gives you a message saying, oh, this is like ransomware. Give me $5,000 if you want to get to work today. We can come up with these scenarios. But the point really comes down to, like, if the car is vulnerable, we just want to get them fixed, so that whatever it is, be it like a teenager messing around or nation state, let's try and secure them to the best of our abilities.
Yeah, I did some episodes on blockchain technology, and there's kind of this, this is maybe stepping into the too much of a techno dystopia realm. But on the blockchain, you could conceivably in the future issue anonymous contracts where you can essentially say, I am anonymous and I am issuing a bounty for somebody else to anonymously do some sort of hacking. And if you do this hacking, by virtue of the way that the contract is constructed, you will receive a payment. So there's this future scenario where we have this market for assassination contracts via hacking, and cars seem like a very susceptible, spooky target for these types of contract hack killings. Is that a discussion worth having here, or is that sort of like, is that so far removed from reality that that it doesn't really even need to fit into our framework here?
Well, I think it's just another one of those things. I mean, you've come up with another financially incentivized reason to hack a car and cause harm to somebody. It's as valid as it is. I also think though, when people are doing research like this, say some regular security people on vehicles right now, they're not that kind of malicious. I think most people understand this isn't changing a website. This is something that could hurt somebody. And I think most people aren't psychopaths. And so, yeah, they're not usually going to do that. Now, you're going to have your outliers. You're going to have your 1%. And I guess anybody doing a Bitcoin bounty to assassinate somebody's that 1%. But again, it's that 1%. So I don't think it's going to be any kind of widespread problem. But you'll have them. And I don't know if that's any different than somebody who's going to drop a bowling ball off a bridge. But, it's what it is.
So you mentioned that you published this Open Garage's Handbook, which is at opengarages.org/handbook if any listeners want to check it out, and I'll put it in the show notes. And you mentioned that when you published it, you were surprised because the people that came to you were mechanics and not security engineers. What does this say about the future of car security? Are we going to have a mechanic and a car computer technician that we occasionally take our car to, or is it too hard to really think about the future in those terms?
I don't know. I mean, I'd like to think we can now bring it in to do some more of it in-house, or, if you have, you have that teenage kid that's really good at computers, that also means they're good at cars, and, they can go over and fix your car. I would be okay with that. But we have to open it up a little bit more to get to that point. The other thing that happened when I released that book's free, by the way. And when I released it, it was just really for that class. I didn't have it in time for the first class, and we had 300,000 downloads in a week. It shut down the ISP I was at. So there's a huge interest in this topic. And this was, I guess, last year, mid-2014. So it's before all these GPACs and whatnot. So there's a lot of people all over the place and from a bunch of different countries, all kind of at the same spot right now. So it'll be interesting to see how this all shakes out.
From a software engineering, a software architecture point of view, what do you think is the best way, or do you have any best practices for, how do you construct a software architecture and versus the hardware architecture of a car? Are there any design patterns for separation of concerns or loose coupling, or thinking about a car is so different than thinking about any other device I've really thought about in terms of software. I mean, I've done a lot of shows on software architecture within enterprises where you have a loosely coupled microservices architecture or service-oriented architecture. But is a car different than that? Do you want a microservices architecture within your car, or have you thought about this subject at all?
Yeah, to a degree, and it kind of varies on who's asking and how their setup is, and typically what I mean by that is, like, the weird thing is they, like I mentioned before, the tier suppliers. So you have these vehicles and they buy components from other people, and we have to get a little bit better at having all those components work together, more than just CAN bus. Because let's just say like over-the-air updates, for instance. It's obvious if how to do like your infotainment unit, who has the internet connection, how it's going to update itself. But what about if your engine control unit that I mentioned, or your body control module, needs an update, and that's owned by another company who provides that? How does that patch come down? How does it get pushed over to the other device? Are there going to be separate radios? Are there going to be one radio? I mean, I prefer the one radio to a bunch of radios in your car, all trying to do the updates themselves. But that's not worked out yet. So I think there's a lot of room for discussion on this. I mean, like I said, we're kind of starting again. This is a fairly new area in automotive. So, start with the threat models, start working through the problems. It's going to be re-architecture for a lot of parts of it.
Why is CAN bus used instead of TCP/IP?
It's because of the efficiency. It's twisted pair differential signaling. So it's these two wires, and they operate high speed, goes about 500K baud. And so the two wires, the way they work is you will go up or down a volt for each bit you're sending. And if they're off, they can disregard it. So you have these really small packets. You can detect any kind of errors that come from static or whatever and disregard them, and get your information where you need to be as quickly and as efficiently as possible and as cheaply as possible. Their cost is also a big concern. They are adding TCP/IP in the newer luxury models, though. So Ethernet is in some of the newer cars. As I said, Tesla has Ethernet. I think BMW's newest one has Ethernet. But the protocol being used on top of it right now, for the most part, is really just CAN push to UDP. That may change, but we're in a transition period.
We've glossed over some of the engineering topics, so I would like to dive into a little bit more engineering side. Could you describe the CAN bus protocol's fault tolerance?
So it's more like in the wiring capabilities. I mean, it has a CRC at the end of it, and it has the wiring differential I was mentioning, which is where you have two wires, a CAN high and a CAN low. CAN high goes up a volt, CAN low goes down a volt, and if they're not in sync, that'll disregard it. If the CRC doesn't match, that'll disregard it. And it's a really tiny packet, so it can get there, hopefully without clogging the bus. So by having a bunch of small ones, I guess one thing I should mention with a bus, it works like a hub. So for those not familiar with a bus system, because there's no source and destination, there's no switch network. So everybody gets to talk at one time and everybody gets to see each other's message. So there's this bus that just runs through the car and everybody just taps into it. And so you'll just send a packet out. Anybody who is interested in that type of packet can just listen for it. And that's the efficiency of the CAN bus network.
So now that we've talked some about some car security internals, can you discuss the Jeep case from the Wired article in any lower level of detail than you've already gone into?
I mean, it's not my research. So
okay, sure.
But it's a similar thing coming over the cellular network.
Sure. So how about this? Could you discuss a recent case or a past case of a customer who came in, an auto manufacturer came in and said, "Hey, could you diagnose this car?" And maybe you found some security vulnerabilities. Then you don't have to say what the company would be, but just kind of maybe as an example.
Okay, yeah, I definitely have to be careful. They're all NDAs.
Sure.
But I guess an example of a vulnerability I've seen is, like, say, there's been a bunch, but one interesting one, I guess, that I know is fixed in at least some of the vehicles, is some of the cars will look for dealership access points. So they know when they're inside of a dealership, there's like a set access point name. And so there's you can obviously just kind of set up your own access point to have that same name. That's something always good to look at as a security researcher, because sometimes the vehicle may have different configurations or more lax security settings if it thinks it's in a dealership. Okay, that's all I want to say about that.
That's fine. So we've talked some about like the car security stuff. We've had heavily connected airplanes for a long time. How does the airplane security model compare to the car security model?
Yeah, unfortunately, I don't really know enough about it. I haven't worked on any kind of airplane projects, so I mean, they sound kind of similar, at least when they're the problems they're dealing with. But as far as the architecture goes, I wouldn't be able to talk to it.
Is there enough attention on the topic of car hacking right now, or should the media be paying more attention? Should the government be paying more attention?
I think we've raised awareness. I definitely think these, like the Jeep hack and stuff, has definitely got a lot of people talking, which is a good thing. Hopefully it'll bear good fruit. Of course, I would always like to see these kind of discussions about like why we should care, what's really going on, what's the real threats, as opposed to, oh my God, your grandma's going to die in a car accident because some kid hacker is going to run into a wall, and those bother me, the sensationalized ones. So I would like to see that kind of detoured into something more like this type of conversation.
What are the kinds of regulation that you would like to see? It
just varies. I mean, the regulation stuff, I don't know.
So regulation maybe not as important as like better engineering practices?
Yeah, I mean, I care more from a technical perspective. I mean, whatever gets you there, gets you there. So if the automotive industry isn't going to step up and do it themselves, then yes, you need legislation to do it. Um, but also, one, if legislation is going to do it, I want them to do it in a sensible way. I don't want it just to be positioning and just getting their name out there. You know, I want it to have some teeth to it. I mean, I don't want you to just come out and say like, yes, we need more security. Let's make a sticker you put on the car, and there's no real bearing as to what gets that sticker on the car. You know, I want somebody just paying some fine or fee and then having some web, say, assessor look at the car and go, oh, didn't see anything, give them the sticker. You know, there has to be some actual technology behind whatever rules you're making.
And you write that, quote, modern vehicle manufacturers have moved away from making it easy to understand your own purchased vehicle, end quote. We discussed this a little bit at the beginning, but would cars that are easier to understand be more secure?
Yeah, I think so. You have it's kind of like that multiple eyes on a problem kind of thing. You'll see things that are overlooked. This happens all the time. This happens in software development. It happens in car manufacturing. And the more people are looking at things, will eventually see something just like, oh, well, you know, if you do this, this other thing happens. And the engineers didn't think of it that way. They design it for a certain purpose. And then all their testing is done knowing what the attributes should be. So they don't usually make mistakes like that, whereas a normal user will make mistakes. They'll guess things. They'll try new things, and they'll share information. So you'll actually get to evolve your product into new mods and just new cool stuff.
Now we're running out of time here, but do you have anything interesting to say about how the general tenor of conversation around hacking is changing in our world? I mean, we have these incidences like this at the Jeep stuff, and then the Ashley Madison stuff, people killing themselves after having their names disclosed on the Ashley Madison list. It feels like hacking is really starting to be able to influence the physical world.
Yes.
So it sounds like you don't have anything other than like. So you don't have any sort of like broad maybe pieces of wisdom that I may not be able to hear from anywhere else.
I mean I don't know whether that's true. I mean everything is pretty much run by software nowadays, and I think a lot of people just are now realizing that. So some of the stuff that used to just be TV fiction is totally doable. And so, it's definitely controlling our physical world.
Okay. And are there any parting words you would like to give to my listeners about car security, car hacking?
Well, if they're interested in doing more of the car stuff, we have like the Open Garages group. It's a free forum. It's not company based. You can just kind of create one in your area or just jump on the mailing list and kind of communicate with other people. So I encourage anybody to go do that, get the book, find an area that they're interested in so they can ask questions. It's a very open community. That's the point of it. So I just get involved.
How hard is it to get started, to bootstrap yourself as a car hacker? What do you need to know? Can you virtualize a car?
I've worked on some of that. So at least the training can be virtualized. One of the tools I have is called IC-Sim. It's on GitHub under Zombie Craig. And IC-Sim is an instrument cluster simulator. It does a full CAN bus. It does need to run on Linux because Linux supports virtual CAN bus. So you can just run it all on your laptop. You can go through exercises of how to do CAN bus hacking, that kind of stuff. I mean, ultimately, you're going to want to at least get parts from a vehicle. You don't have to own the full car. I recommend going to a junkyard, pulling parts from a junkyard, and then working on those. You can build what we call a test bench. You give it power. You can build the pieces you want to focus on and come up all your research that way.
Great. Well, Craig Smith, thanks for coming on to Software Engineering Daily. It's been a pleasure talking to you.
Yes, nice. Thanks for having me on.